So see, this is the problem number 3.45. Capacitor consists of two round plates parallel, each having radius r. These two round plates, each having radius r, separated by a distance L and small distance. So L is much smaller than r, and having charge density plus sigma and minus sigma. Find the potential of the field and the field strength at the axis of the capacitor as a function of distance x. So x should be actually the distance of this point P from the midpoint of the capacitor plates. Okay, and find potential and the field and its strength. Okay, that's it. And investigate the expressions if x is much larger than r. That we will do later, but for solving this problem we need to find out the potential and field near a charged plate having charge density sigma. So this is how you go about the calculation. A plate of radius r, surface charge density sigma, and this is the point P at which you will find field and potential. So you divide it into little rings, rings of little thickness, rings of radius r and thickness dr. So this is a ring. So this point is equal, this point P is equidistant from all points on the ring. So distance is root over r square plus x square. So the charge on the ring is this sigma into 2 pi r multiplied by dr. Okay. So potential at point P due to the ring is 1 by 4 pi epsilon naught charge on the ring divided by distance. So now you have integrated from 0 to capital R. So small r will be from 0 to capital. Here x is constant. So in this way we substitute z equal to r square plus x square. So dz equal to 2r dr. So you make a substitution here. So here you get sigma by 4 epsilon naught into integral of 2r dr divided by r square plus square, and the limit will be from 0 to capital R. So here you get sigma by 4 epsilon naught, so integration of dz by z. So dz by z is 2 root z, so 2 root over r square plus x square. If you put the values you get this. This is the potential, and if you differentiate potential, now you have to make this x variable. So E is minus dv dx. So this is sigma by 2 epsilon naught 1 minus x by root over r square plus x square. At this point P, at a distance x from the center of the disk, field and potential we have found out. Now here I'll take this as x. See, instead of taking x here, I have taken it here. Doesn't matter because this L is very small. So this is L. Okay. So at point P, potential is due to this plate and due to this plate. So due to this plate, this first term, and due to this plate, this second term. Right. We have used that same formula we have derived just now. So there you go. V is like this, right? You take here L common, so multiply by L and divide by L here. So this will be. See, now a special thing we are doing. This. See what we have done actually. This root over of. Just a minute. So this term we have root over of r square plus L plus x square minus root over of r square plus x square by L. Now this I can take here. So as L is very small, so we can consider it as like this. So this ultimately its limit L tends to 0, right? Limit L tends to 0, root over of r square plus L plus x square minus root over of r square plus x square. So this is actually differentiating root over r square plus x square. So this L is approximately dx, that is what we have assumed. So that here the result will become root over of r square plus x square multiplied by x. So this is the result we have used. See, x here it will be x by root over r square plus x square minus 1. So this is the value of potential. Now the field again differentiate it minus dv dx. After differentiating you get this, and after some approximation you reach at this value. Now in the next part of the problem it is asked that if what will happen if x is much greater than r. See, you can apply the approximation from the equations, but I will tell you what is going to happen if x is much less than r, right? If x is much greater than r, then it's actually a dipole. If for a very far away point, the plates will be like point charges. So this point charge plus q and minus q, what will be q? Sigma into pi r square. So here the field due to dipole is how much? 2 into 1 by 4 pi epsilon naught. So this L. So this dipole moment equal to q into L. So it's p by x cube. And potential is p by x square. If you substitute the values, having q, this, and p as this, will get the value of potential and field.